Okay. You should know that I is equal to the square root of negative 1. It's imaginary. We want to find I to the 11th power. Now, for some people that might be kind of, whoa, what the heck does that mean? Well, there's a pattern to your I values. What you have to realize, we said I is equal to the square root of negative 1. I squared, well, what happens when you square square root? You get, for instance, I squared is equal to the square root of negative 1 squared. Okay? I squared, I is the square root of negative 1. Whenever you square a square root, do you understand the square root drops out, leaving you negative 1? So, I squared is negative 1. Next, I to the third, well, isn't I to the third just I times I squared? So I is the square root of negative 1, and isn't I squared negative 1? So what's square root of negative 1 times negative 1? It's negative square root of negative 1. Okay. I to the fourth, isn't that just I squared times I squared? Isn't that just negative 1 times negative 1? I squared times I squared? It gives me 1. Okay? So, there's a pattern here. When I get to I to the fifth, I to the fifth is I to the fourth times I. So I to the fourth is 1 times the square root of negative 1. You go back to the square root of negative 1. Here's the pattern. It goes from square root of negative 1 to negative 1 to negative square root of negative 1 to positive 1, and then the pattern repeats itself. Okay. Once the pattern repeats itself, you just got to think of every 4 it repeats. So, how many times does 4 go into 11?
2.
Okay, if you take 11, how many times does 4 go into it? It goes twice. Leaves you 8, correct? Remainder of 3. Meaning, my answer would be 2 3/4. Do you understand that remainder of 3 means you went through it twice? Doesn't that mean it's now on the third cycle?
Correct.
Which means it's y to the third, which is negative square root negative 1 is your answer.
Ooh.
Now, what you do again is you got to know this pattern of I squared, I to the third, I to the fourth, and go every fourth. So basically you take the power, divide by 4, and then your remainder is which of the 4 it is. Now, if that makes no sense to you, what you could do, and this is even harder in my mind, but what you could do is use I and I squared to create I to the 11th. And what I mean by that is I to the 11th is I squared times, isn't that I squared to the 5th? 5 of them? And 1 I? 5 I squareds and an I. Does that give you I to the 11th? 5 I squareds and 1 regular I. Does that give you I to the 11th? Yes. Okay, what's I squared? Isn't I squared negative 1? So wouldn't that be negative 1 to the 5th power times the square root of negative 1? What's negative 1 to the 5th power? Negative 1. Negative 1 times square root of negative 1. Is that the same answer? There's multiple ways. You can either look at your I squareds and your I's and create I to the 11th, or you think of the 4 pattern of 4s, and you go for every 4 to find the answer. There's 2 different methods. Okay, so this one was right there. There's your answer. Number 2, plot these numbers. It's real simple. Negative 4 plus 2i. You have to first realize this is your real numbers, and you have to know this is your imaginary numbers. Real numbers, imaginary numbers. So for real numbers, I have negative 4, which means I go over 1, 2, 3, 4. The 2i means I go up 2i. Negative 4, up 2i. This one, you have to realize you go over 0. Can you put a plus 0 here if you want? So that means I go over 0 on my real, but my imaginary tells me to go down 3. Sorry. There's A, there's B. Remember, you go over 0, but it tells you to go down 3. And C is plus 0i. So basically that's saying go over 4 and go up nothing. So it stays right there. All imaginaries have a real part, which goes on the real axis, and an imaginary part that goes on the imaginary axis. These are basically, you could think of them also as negative 4, 2, as coordinates, negative 4, 2. The imaginary is your y-axis. The real is your x-axis.